Hello everybody, this is Mr. Birajdar Balasaheb, Assistant Professor, Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. In this video lecture, we will discuss Laplace transform by first shifting theorem. Learning outcomes. At the end of this lecture, students will be able to apply the first shifting theorem to find Laplace transform of given function. Let us start with statement of first shifting theorem and its proof. Statement is, if Laplace transform of f of t equal to f of s, then Laplace transform of e to the power at into f of t equal to f of s minus a. Now by definition of Laplace transform, we know that Laplace of f of t equal to integration of e raised to minus st f of t dt over the range t equal to 0 to infinity. Now replace f of t by e to the power at into f of t in both the side. We get Laplace of e raised to at into f of t is equal to integration of e raised to minus st into e raised to at f of t dt over the limit 0 to infinity. Now simplify e raised to minus st into e raised to at. We get Laplace of e raised to at into f of t equal to integration of e to the power minus of s minus a into t f of t dt over the limit t equal to 0 to infinity. Now for sake of simplification, let us take s minus a equal to u. We get Laplace of e raised to at into f of t equal to integration of e to the power minus ut into f of t dt over the limit t equal to 0 to infinity. Now the value of this right hand side integration with respect to t is a function of parameter u. Therefore, it is denoted by f of u. Therefore, Laplace of e raised to at into f of t equal to f of u. Now substitute the value of u as s minus a, which is assumed. Therefore, Laplace of e raised to at into f of t is equal to, we get f of s minus a. What it means? It means that to find Laplace transform of e to the power at into f of t, simply we replace every s equal to s minus a in the Laplace transform of f of t. Similarly, we can write Laplace of e to the power minus at into f of t is equal to f of s plus a. Here, we have to replace every s equal to s plus a while in Laplace transform of f of t, while finding Laplace of e raised to minus at into f of t. Now let us see examples. Example 1, find the Laplace transform of e to the power 3t into bracket cos 5t minus hyperbolic sine 2t. Now by linear property, Laplace transform of e raised to 3t into bracket cos 5t minus hyperbolic sine 2t can be written as Laplace transform of e to the power 3t into cos of 5t minus Laplace of e raised to 3t into hyperbolic sine 2t. Denote this equation by 1. Now from Laplace transform table we learned already in video number 1 and 2. Laplace transform of cos of 5t equal to, we can write s upon s square plus 5 square, but 5 square is 25. Therefore, Laplace of cos of 5t is s upon s square plus 25, denoted by f of s. Now by first shifting theorem, Laplace transform of e to the power 3t into cos of 5t is obtained when we replace every s by s minus 3 in Laplace of cos of 5t. So we get Laplace of e raised to 3t into cos of 5t is equal to s minus 3 upon square of s minus 3 plus 25. Similarly, First we find Laplace transform of hyperbolic sine 2t by using Laplace transform table. It is 2 upon s square minus 4 and denote again it is f of s. Again by first shifting theorem, Laplace transform of e raised to 3t into hyperbolic sine 2t is obtained when we replace every s equal to s minus 3 in Laplace transform of hyperbolic sine 2t. We get Laplace of e to the power 3t into hyperbolic sine 2t is equal to 2 upon s minus 3 bracket square minus 4. By substituting these two results in equation number 1, we get Laplace transform of e to the power 3t into bracket cos of 5t minus hyperbolic sine 2t is equal to s minus 3 upon square of s minus 3 plus 25 minus 2 upon s minus 3 bracket square minus 4. Now pause the video for a while and think about the question and write the answer in your notebook. The question is, find the Laplace transform of e to the power minus 2t into t. Come back. I hope you have written answer to this question in your notebook. Here I will going to explain answer for the question Laplace transform of t into e raised to minus 2t. Now first of all find Laplace transform of t using Laplace transform of elementary function t raised to n formula, that is Laplace of t raised to n equal to gamma of n plus 1 upon s raised to n plus 1. We learned it in video 2. Put n equal to 1 in both the side, we get Laplace transform of t equal to gamma of 1 plus 1 upon s raised to 1 plus 1, which is equal to gamma 2 upon s square. But we know that by property of gamma function, gamma n equal to n minus 1 factorial. Therefore, gamma 2 means 1 factorial, it is 1, and that's why Laplace transform of t equal to 1 upon s square. Let us assume it is f of s. Again by first shifting theorem, that is Laplace of e raised to minus at f of t equal to f of s plus a. Therefore, Laplace of e raised to minus 2t into t is obtained when we replace every s equal to s plus 2 in Laplace transform of t. We get Laplace of e raised to minus 2t into t is equal to 1 upon square of s plus 2. Now let us consider another example. Example 2. Find the Laplace transform of hyperbolic cos at into sine bt. Here first of all express this hyperbolic cos at in terms of exponential function using definition of hyperbolic function. Hyperbolic cos of at equal to 1 by 2 in bracket e to the power at plus e to the power minus at. Therefore, hyperbolic cos at into sine bt equal to 1 by 2 in bracket e raised to at plus e raised to minus at into sine bt. Now multiply sine bt inside, we get which is equal to 1 by 2 into bracket e to the power at into sine bt plus e to the power minus at into sine of bt. Now taking the Laplace operator on both the side and separate Laplace operator for each term in right side by linear property. Therefore, Laplace of cos hyperbolic at into sine bt is equal to 1 by 2 into bracket Laplace of e raised to at into sine bt plus Laplace of e raised to minus at into sine bt. Now from the table of Laplace transform, we know that Laplace of sine bt can be written as b upon s square plus b square and denote it as f of s. By first shifting theorem, we can write Laplace transform of e raised to at into sine of bt, which is equal to b upon square of s minus a plus b square. Replace s by s minus a in Laplace of sine bt, we get this result. Similarly, for Laplace transform of e raised to minus at into sine bt, simply replace s by s plus a in Laplace transform of sine bt, we get it is equal to b upon square of s plus a plus b square. Substituting these two results in above equation, we get Laplace of hyperbolic cos AT into sin BT is equal to 1 by 2 into bracket b upon square of s minus a plus b square plus b upon square of s plus a plus b square. Now to prepare this video lecture, I refer these two engineering mathematics books as a references.